module 11, 15.4. So this video, we're gonna begin to multiply with radicals. Okay. So back in module 15.2, I wrote there was a rule or a property says if I have a square root of a times square root of b, then we can write them as square root of ab. I think maybe it was written backwards, so let me write it backwards. So that rule back in square root of AB can be written as square root of A times square root of B. So basically what it's saying is, if I have a radical and inside of it is one term, I can split them into multiple terms. Now we're going to look at it from the multiplication perspective. If I have radicals, okay, that has the same roots, just the same roots, I can actually simply just multiply what's in the inside, because technically I can put them all back underneath the same roots. Okay, so by knowing that, I can rewrite this square root of 3 times square root of 12 as square root of 3 times 12. And I can say this is square root of 36, which we know square root of 36 is going to be positive 6. Okay, this is one way we can do this. All right, another way we can do this is actually do this without writing them all underneath the same roots. Okay, we kind of do it, we just don't actually write them out. Because if you think about square root of 12, if you think about the 12, this 12 is 4 times 3, which we know 4 is square root of 4, or 4 itself is 2 times 2. So basically what I have under the roots is 2 2's and a 3, because technically I can write them all together under the same radical. Okay, so 2 2 go outside as 1 2, 2 3 goes out as another 3, so 2 times 3 will give me my 6. We can do it this way too, just by looking at it. So we know they can be put under the same square root, but so this technique is simply saying we're not going to write them out like that. We're just going to break them down like it is, and then see how many of the same number I have to go outside. So sometimes this technique is more convenient, sometimes it's not as convenient. So it really depends on the nature of the problem. Okay, unless so it also depends on individual student how much you want to write things out. All right, now problem look like this will be simply a distribution. Okay, so a lot of times when I'm looking at this problem, I know square root of y gotta multiply. So when we multiply, we can simply just multiply what's in the inside. I don't need to kind of break anything down initially because there's nobody can come out anyway. So square root of y times square root of x is going to be square root of xy. Square root of y times negative 6 square root of y. That should be negative 6 square root of y times y is y squared. So these two y's, or y squared, was going to cancel out with a square root, or you can say these two y will come outside as 1y. So my final answer is going to be square root of xy minus 6y. Okay. So inside multiply inside, outside coefficient multiply with outside. Okay. All right. So 2 term times 2 term. So now let's do basically a FOIL method involving with radical. Okay. So let me scoop this over a little bit. So basically, after a while, when you see 2 times square root of x times 6 times square root of x. Square root of x times square root of x is square root of x squared, or x times x. So x and x squared will cancel out, so you should have an x comes out. 2 times 6 is 12. 2 times square root of x times positive 5 square root of y. 2 times 5 is positive 10. Square root of x times square root of y is square root of xy. So that's my outer. Let's do inner. Negative square root of y times positive 6 square root of x. That will be negative 6 square root of xy. All right, now the last thing I do, negative square root of y times positive 5 square root of y. So the square root of y times square root of y is going to be square root of y squared, or y times y. Square and square root cancels out, y will come out. By the way, negative times positive is negative. Let me see what. Oh Lord, what's going on here? Let's not mess with it for right now. All right. Ooh. Negative times positive is negative, so that would be negative 5. All right. Square root of y times square root of y would just be y, so that would be negative 5y. I believe what I got myself here in the middle, these two are like terms because the roots are the same. What's inside the radical are the same, and the coefficient outside are like terms. So I'm gonna combine them. So 12x minus 5y, 10 minus 6 become positive 4 square root of xy. Now, I purposely moved my negative 5y up front. I can do that, or maybe I don't have to. In the next few lecture video, once we finish up multiplying and dividing with radical, we will begin to take a look at our imaginary numbers. And then, when we talk about imaginary numbers, normally we put the radical term on the very back. Okay, if that's the only term we have. So, not a big deal right now if you want to leave the negative 5y on the back. I just begin to, I always at this point begin to write most of my radicals on the back side of it. Okay. Now for this one, I didn't want to move anything. Let's try this one. This is a very interesting problem. So square root of 6 times square root of 6, that becomes square root of 6 squared, which over square root of 36, or square root of 6 times 6. Either way, the answer is 6. Square root of 6 times negative 5. That will be negative 5 times square root of 6. Now, why don't I take my 5 times the 6? Because one is on the outside, one is on the inside. They cannot be multiplied. So inside times inside, outside times outside. All right, in there, positive 3 times square root of 6 is positive 3 times square root of 6. And I'm not even trying to break down my 6 because that's only 1, 2, or 1, 3. So there's no need to break them down. Positive 3 times negative 5, that will be negative 15. All right, combine like terms. 6 minus 15, negative 9. I'm going to put it in the front. Leave my radical term on the back side. So those two are like terms. Negative 5 plus 3 is negative 2 times square root of 6. So that's my answer. These two terms are not like terms because my negative 9 don't have a radical with it. So we just leave the answer like it is. All right, this is exactly two terms in two separate parentheses multiplied together. So as you know, this problem can be written as square root of 2y plus 4 whole thing squared. So that brings us back to our perfect square binomial. All right, so let's see if I can find it real quick on the formula sheet. Maybe I did not put on here. All right, perfect square binomial. A plus b whole thing squared is a squared plus 2ab plus b squared. We can use that. Or we can simply just FOIL them out. So I just want to refresh your memory. If we go with the perfect square binomial, square root of 2y is your a, 4 is your b. So your a whole thing squared will simply just be, well, square and square root cancels out, so that would just be simply 2y. All right, plus take a number 2 times your a times your b, 2ab. So the 2 and the 4 on the outside can be multiplied, so that's positive 8 times square root of 2y. Plus your b, which is 4, got to be squared, so that's 16. So I'm going to rearrange this a little bit. I'm going to leave my radical on the back, so that's 2y plus 16. plus 8 times square root of 2y. Alright, so none of them are like terms. Or if you want to forward out, square root of 2y times square root of 2y will be square root of 2y whole thing squared. So again, square and square root will cancel out. That leaves me with 2y as the first term. Outer is 4 square root of 2y. Inner is another 4 square root of 2y. So that gives you 8 of them. And positive 4 times positive 4, positive 16. Now I did demonstrate doing the FOIL method by looking at them before. I didn't quite do that here because I do want to write it out. Since we're dealing with radicals, something we're not as familiar. Alrighty, while I'm at this, I'm gonna kind of change, I'm gonna do exactly the same problem. I'm gonna change the 1 and the plus sign to a minus sign. So this is an interesting one because this problem relates to when it comes to dividing. Believe it or not, when it comes to dividing with radicals, we need this. When part of it is actually look something like this. If I have a square root of 2y plus 4 times square root of 2y minus 4, all right, this look just like a difference of squares, because here I got ourselves an a plus b times a minus b. So if you can recognize that this is a difference of square, then you can simply say your a, which is square root of 2y, whole thing squared, minus your b, whole thing squared. So our ability to recognize perfect square binomial and difference of square will really come in handy when it comes to college algebra class. Alright, so now square and square root cancels out. I just end up with a 2y minus 16. Okay, so very interesting problem because difference of square allows me to cancel out my radicals. Okay, difference of square allows me to cancel out my radicals. So my answer actually does not have any radical expression in them. Alright, so just a quick lesson on how we can multiply our radical expression. That will conclude this lecture video. Thank you for watching.